Chapter 2, this is your Professor Lázaro Pino. Well, this class is maybe one of the most important ones in this chemistry 1405. Why? Because it's the basement of all the calculations you are going to do until the last chapter. So follow this instruction, study them very, very careful. We are going to speak about measurements and calculations. Well, what is a measurement? It's a quantitative observation. Uses numbers and units. Don't forget that it's not only a number, it's also a unit. The number tells comparison. Comparison with a pattern. For example, if you are going to measure length, we can use the inch or the centimeter according with the system that you are using in your measurement. And the scale, well, even though you are using inches, your scale can have only inches or can have half inches or can have a quarter inches or 1/8 inches or 1/16 inches or 1/32 inches. Depending on the scale, well, it will be the accuracy of your measurement. Look at this. In chemistry and in all the sciences, we use what we call scientific notation. Scientific notation, well, you have studied already in other classes, but I'm going to speak about this a little bit. First of all, you will change large or very small numbers into a small number that is between 1 and 10 here, 1 and 10, never 0, between 1 and 10. And then you will multiply this small number by 10, and the power will be the number of times you have moved the 0. Look at here, for example, the 0 is here at the end of this big number. Then what you do, you move to the left 1, 2, 3, 4, 5, 6, and 7 times. Then you will have 9.3 times 10 to the 7. That is the number of steps you have moved the dot to the left. Look at this. I am not writing here the 0. It's supposed that you don't have here a dot. If you have a dot, it's a different thing. But in this case, as you don't have a 0, a dot here, sorry, these zeros are trailing zeros and are not considered significant, so you don't write them here in the scientific notation. We are going to speak about this later. Look at this. You move the decimal point to the, in this case, to the right or to the left, and you multiply by the power of 10. The direction to move of the movement, sorry, determines whether the power of 10 is positive or negative. If you move to the left, it's positive. It's because you are in front of a very large number. But if it is a negative, then you move to the dot to the right. And it means that your number is very small, so the power is negative. Look at this. In this case, as I told you, you move the dot to the left 7 times, though, so it will be 9.3 times 10 to the 7. Oh, but what happened if it were a very small number? Then it will be negative. Look at this. This is a very small number. Then what you do? You move the dot 1 and 2 in order that you get here a number that is between 1 and 10. Never can be 0 here. Then you move 1 to the right. Then you type here 6.71 times 10 to negative 2. Negative because the movement is to the right, and 2 because it's the number of times you move the dot. Remember, when the number is small, the power will be negative. When the number is big, then the power will be positive. In this case, I move the dot 1, 2 times to the right, to the left, sorry, so the power will be 2 positive. Which of the following correctly expresses this number in scientific notation? Well, what you do? You say, well, the dot is supposed to be here. Then I have to move 1, 2, 3 times. 7.882 times 10. Oh, you move to the left, then the power is positive. How many times? 3 times, and it will be cubed. Then the answer, as you can see, is this one. Look at this. Here we have a very small number. Then we are going to move the dot 1, 2, 3, 4, 5 times. 4.96 times 10 to the minus 5. Then this is the correct answer. Well, in a system of measurement, we have what we call unit, the scale of a standard being used to represent the results of a measurement. Scientists require common units to measure quantities such as mass, length, time, and temperature. The systems that are used here in the United States are the English system, but all over the world is used the metric system. That is all is represented by SI because it comes from French and is international system. Comprehensive is a comprehensive system of units set up by an international agreement and are units that are based and derived, sorry, from the metric system. In the international system, the units of mass, well, in the unit of mass is the kilogram. For length, the meter. For time, the second. For temperature, Kelvin. For electric current, ampere. And for amount of mole of substance, mole. Well, here is the abbreviation of these units. What is important in the international system? Oh, that you use prefixes, and every prefix represents a power of 10. For example, mega represents 10 to the 6, kilo represents 10 to 10 cubed, deci is 10 to minus 1, and so on. Same way, here you have a, for example, that 1 kilometer is 1,000 meter, or you can say also 10 to the 10 cube to the third meter. Okay, 1 meter is the unit of length. For decimeter, then it's 10 to minus 1. For centimeter, it's 10 to minus 2. For centimeter, for milliliter, 10 to the minus 3, and so on. Volume is the measure of amount in 3 dimensions. Is the space occupied by a substance. In the international system is the cubic meter. Commonly measured in cube centimeter, 1 milliliter is equivalent to 1 centimeter, cube centimeter. I want you to understand something. Even though the milliliter and the cube centimeters are equivalent, milliliter is the substance inside of the volume, and the cube centimeter represent the empty volume. Also, you have the 1 liter is 1 cube decimeter. For mass, we use the kilogram. The kilogram is equal to 2.2046 pounds. Or also you can say that 1 pound is equal to 453.59 grams. This, I recommend you to take these units into account, because you are going to use them in the conversions for this homework and for the first exam. Here we have a concept check. Well, let's see. Choose the statement that contains improper use of commonly used units. A gallon of milk is equal to 4 liters of milk. That's true. A 200 pounds man has a mass of about 90 kilograms. If you divide 200 pounds by, or you convert the pounds into kilogram, you will see that this is true. A basketball is 7 meters tall. That's not true. A nickel is 6.5 centimeters thick. That's not true. It's impossible, you know. 6 centimeter is you can have a lot of nickels in this size. And the same thing with 7 meters tall is a very tall man. Okay, let's see. Certain and uncertain. A digit that must be estimated is called uncertain. A measurement always has some degree of uncertainty, but certain digits are recorded first, followed by uncertain digits or the estimated number. For example, if you are doing a measurement of a stick, this is a stick, and you see that here is 1 inch, 2 inches, 3 inches, 4 inches. Okay, 1, 2, 3, 4. You're certain that your stick is 3 inches. Oh, but what happened? That you're not sure if it is 3.5 or 3.6 or whatever. Then this digit is estimated. This is certain, but this is estimated, and depends on the instrument that the precision of the instrument that you are using in your measurement. Here you have, for example, you are doing the measurement for these of this nail, and you can see that is between 2.8 and 2.9 centimeters. And 2 is certain, but 9 or 8 is uncertain. Sorry, I made a mistake. It's between 2.8 and 2.9. Then 2.8 is certain, but you don't know if it is closer to 2.9 or less closer to 2.9. Then you estimate that is in the middle, and you say, well, it's 2.85. The 5 is the uncertain digit. Pay close attention to these rules. What are significant figures? Don't forget that if you make a calculation and you don't report the number of significant figures, I will consider it incorrect. And you are going to lose all the points, at least at the beginning during this unit. Later, maybe I only take some points from you. Well, a non-zero integer always count as significant figure. Then in this number, all the numbers are different from 0. Then they are significant. And we can say that we have 1, 2, 3, 4 significant figures. Zeros, there are 3 zeros, 3 classes of zeros. The leading zeros are the zeros that are to the left of the first number different from 0. These zeros are never significant. The captive zeros are the ones that are in between. They are considered significant. And the zeros that are at the end and you don't have a decimal point, these zeros are considered trailing zeros and are not significant. For example, in 9,300, you have only 2 significant figures because these zeros are not considered significant. Same thing here in 150, this zero is not considered significant and you report only 2 significant figures. Stop the video, go back, and try to learn it by heart. This is one of the concepts that you have to learn by heart. What are exact numbers? For example, 1 inch is equal to 2.54 centimeters. This is an exact number. 9 pencils, 10 chairs, 2 dresses, or these are the result of counting, then they are considered exact numbers. Let's see, here we have an example of potential scientific notation, sorry. For example, 300 written at 3.00 times 10 to the second. You have here 3 significant figures in this case. If you write this way. But if I were you, look, as you don't have here a decimal point, this is incorrect. because these zeros at the end are trailing zeros, are not considered significant. And the answer will be 3 times 10 to the second. And you report only one significant figure. As you can see, here is a mistake. Well, the number of significant figures can be easily indicated. As you can see, fewer zeros are needed to write a very large or a very small number. That's why we use scientific notation. What are the rules for rounding off? Well, this is the same thing as you have studied before. If the first number that you are going to skip is lower than 5, then you drop it. But if the last number you're going, or the number you're going to skip is higher than 5, then you round up. All right? Okay. Let's continue. Let's continue. Here you can continue looking at your PowerPoint. And for multiplication, look at this. This is very important. When you're multiplying and you have two factors, you pay attention to the factor with least significant figures. It has two significant figures, then you have to report two significant figures. This is in multiplication. And same thing when you are dividing. But if you are adding or subtracting, well, you put the numbers this way and you make a line by the number with least digits. The least digits is this number. So you make a line here, you say, I will skip this digit. Oh, it is 5, then I have to round up. And you report this as the final answer. This is in addition and subtraction. Then even though you are using a calculator, you have to do this way the operation in order to know what is the number of significant figures to be reported. Well, for example, here you have a graduated cylinder. Then you add to both samples, you add both samples of water into graduated cylinders. How could you write this number? Well, you say the liquid is here. This is the lower part of the meniscus. So you put your eye here and you watch this way. You say, well, the meniscus is in this line. It's higher than 2, but it's not 3. Then between 2 and 3, you have 1, 2, 3, 4, 5 lines. Then you say 3 minus 2 is 1. And then you divide 1 by the 5 lines, and you will see that every line is 0.2. Then you say 2.2, 2.4, 2.6, 2.8, 2.8. Then this is the answer for this measurement. All right. Here is, they say 3.1 milliliter. 3.1 milliliter cannot be here. It must be here. Then that's a mistake. As you can see, this is 2.8 because the liquid is below the level of 3. Okay, dimensional analysis. Well, here you can stop the video, you can read this careful, but I prefer to go through an example. For example, a golfer put it a golf ball 6.8 feet across a green. How many inches does this represent? Then you need what is given. It is given in feet. And you need to go or to represent this into what? Into inches. So you know that 1 feet is 12 inches. So you can write two factors. You can say that 1 inch is 12, for 1 feet is 12 inches, or 12 inches is 1 feet. Which one of these two factors you are going to use? Let's see. Let's put here the number that is given. It is in feet. Oh, if it is in feet, the conversion factor that I am going to use must have feet down and inches above in such a way that you cancel this with this, and your answer will be in inches. So you need to use this conversion factor. If you multiply this by this, you can get the answer. The answer is 28 inches. Why do you say 28 inches? Oh, because you have here two significant figures, and then in your answer you have to report two significant figures. This is what we call dimensional analysis, and this is one important thing that you cannot forget at any time. For example, an iron sample has a mass of 4.50 pounds. This is the given number. And what is the mass in grams? Well, first you convert grams, pounds into kilograms using this conversion factor in such a way that you cancel pounds with pounds. And later you use this conversion factor in such a way that you cancel kilograms with kilograms. And here you get the answer. As it will be a very big number, you use scientific notation. And the number of significant figures to be reported must be the same one as the number of significant figures in the given number. Don't forget that. Well, that's all for now. I hope you understand. Please go over scientific notation, go over significant figures, go over the international system.